Hello everyone, welcome to our course. This course is Hadoop Big Data Platform and Technology. And from the title, you may find that it is mainly about the basic knowledge about Hadoop. And don't worry if this is your first time you've heard of Hadoop, because we will introduce you to the basics of it. Okay, before jumping into the main lecture, at first we can have a look at the objectives on this course. We hope that after this course, you can be able to get familiar with the Hadoop ecosystem, be familiar with the functions, features, application scenarios, and operating principles of components in the Hadoop ecosystem, and understand the component architecture of the Hadoop ecosystem. In short, we will cover the basic knowledge about Hadoop, and if you find it interesting, this course may become the startup for your later study. All right, so now let's jump into the first chapter about an introduction to Hadoop Big Data Platform. In this chapter, we will give you an overview about Hadoop. Before we introduce Hadoop, we know that, in fact, there are just various kinds of data processing systems available. Like what we can see from the graph, this is just an architecture of a widely used traditional data processing systems built up based on some mid-range computers, network, and disk storage as the infrastructure, and manage data with relational databases or data warehouses like DB2, MySQL, Sybase, and Teradata, etc. And with the help of some application middleware, as well as some application frameworks and platforms, the system can be used to provide services like some topic-based applications, including financial analysis, telecom analysis, social analysis, you name it. Besides, it can also provide applications like drawing some analysis reports, doing some data query or KPI analysis, or some more general OLAP data analysis, or self-service analysis. So this is just what we have already been using for decades. And honestly speaking, these traditional data processing systems are still there in some banks or enterprises nowadays. But with time passing by, especially when we are standing at the era of big data, people find many problems occurring with traditional data processing systems. Here, you can find 6 problems. First, because of the feature of big data, the data volume is too large, and diversified formats of data requires the data schema evolving frequently. Plus, the value density of big data is as low as the density of gasoline from the raw oil. So we can expect that if we are still using the traditional structure, there will be very high storage and processing costs. Secondly, the system is highly coupled, which means that the scalability is very limited. If the data volume keeps growing, we need a new system. Thirdly, the traditional system may focus on what we have already got in the databases, but it is not good at dealing with the external value-added data assets, which means that the enterprises cannot keep pace with the evolution of the external market and gradually being lagged behind. Firstly, it cannot provide sufficient big data processing capability. Namely, it cannot deal with data sets with volume of hundreds of gigabytes or even terabytes in a limited time. Fifthly, the data source of this system is lacking of flexibility, and we can only choose the traditional data sources in most cases. Last but not least, the traditional data processing system could merely deal with data in batches, which means that it needs to wait until all the data arrived, then starts the computation. But in big data era, in some cases, we are not allowed to wait so long. Instead, we need to process the streaming data and as soon as every piece of data arrives, or namely, the processing is driven by every event. So, because of the 6 problems, we can draw a conclusion that the traditional data processing processes, storage, network, and database will become new bottlenecks, and the traditional technical models cannot meet the requirements of big data processing and analysis. That is just the reason why we need a new system called Hadoop. However, as the old saying goes, Rome wasn't built in one day. So, the data processing technology has an evolution trend as follows. Let's take a look at the very first and simplest architecture. This architecture has a name called SMP server, which stands for Symmetric Multiprocessing Server. It integrates a group of processors on a single computer, very similar to your PCs. And all CPUs share the same resource pool, which means that they are fully coupled together. So, simply speaking, usually it is built up based on a single node system. Therefore, it may meet performance bottlenecks very frequently, and whenever it meets performance bottleneck, we could only provide better hardware like better CPUs or better memory, which is known as a method called scale up. In this case, the scalability is very poor. So how to make it better? Yes, the single node architecture has many limitations. Then, how about using many servers to deal with the same tasks in parallel? For example, if one server is not good enough, then we can use 10 servers to deal with the same task together. Yes, we can. And this idea is called distribution. Namely, we can distribute data to multiple servers, and all the servers together as an entirety is called a computer cluster, or in short, a cluster. But still, the cluster in this stage is just a very simple computer cluster, and the most significant feature of this distributed cluster is that it shares everything. What does that mean? As the name tells, share everything means that single host transparently shares the CPU, memory, and I/O resources. This means that the servers in this kind of cluster share the same resource pool. In this case, although we have multiple servers working in parallel, but they are still highly coupled together. Therefore, the parallel processing capability is terrible, or namely, the scalability is still very bad. Then, can we decouple them? That is exactly what we have done in the third stage. And in this case, the servers share nothing. So likewise, share nothing means that Each processing unit has its own private CPU, memory, and hard disk, and does not share resources. In this case, it has a particular name called a massively parallel processing mode, or MPP mode in short. Now, each node is independent of each other and processes its own data, and different processing units communicate with each other through protocols, achieving better parallel processing and scalability. In short, it does not share resources anymore. So now, servers are decoupled, and thus the scalability is high. And if we think the performance is not good enough, just simply add more servers into the cluster and then modify the configuration for new servers registration. That's enough. So you may think this stage is good enough, right? Actually, some experts think so as well. And that is why this structure is still widely used in many industries, including large commercial banks, government agencies, and some telecommunication enterprises, and so on. This kind of industries do not have a very high demanding on semi-structured data analysis like web page clicks analysis or unstructured data analysis like image analysis or video analysis. Thus, MPPDB seems just fine. But in some other enterprises, including Google, Facebook, Amazon, Uber, and also in Huawei, we have a very urgent need for semi-structured and unstructured data analysis capability. So, the MPPDB is not good enough. Therefore, we need new technologies, and thanks to Google and many other internet enterprises we mentioned before, there is Hadoop. It is still a share-nothing architecture, but the storage and processing engine is not only traditional databases. For data distributed storage, we can use a distributed file system called HDFS to store data in the format of files and manage files in the way as we are using Linux file systems. And for data processing, we can use MapReduce and Hive to do batch data analysis with data size in petabyte level, or use Spark and Flink to do real-time data analysis with millisecond level latency. So now you can find how powerful Hadoop is. And so this is just how data processing technology evolves. And again, the main target for this course is to show you the most basic knowledge about Hadoop and the powerful components in Hadoop. And there, you can find the Hadoop ecosystem architecture. So as the title shows, Hadoop nowadays has been a very big ecosystem. And in this ecosystem, we have many different components for different purposes. Here, you may find a little bit headache because there are so many names. Don't worry, you do not need to remember them all right now because here we just give you the first impression about them. Later, we will give introduction to most of them in different chapters. And now, you just need to be familiar with their names. That's enough. So at first, let's have a look at the one on the bottom, which is called HDFS. HDFS is a reliable distributed file system. This is the basis of the whole skyscraper of Hadoop because all the upper layer components need to read data from HDFS. So in short, HDFS provides petabyte level storage services. Above it, we can find MapReduce. which is for parallel computation of terabytes of data in a distributed way. And YUM, which is for distributed resource coordination. As we mentioned before, the Hadoop cluster share nothing, but how can we manage the resources in a proper and unified way? That is just the responsibility of YUM. So simply speaking, MapReduce here is for parallel computation, and YUM provides CPU and memory coordination for the whole cluster. And then above them, we can find database, which is a distributed and high-dimensional NoSQL database in Hadoop. This is a database not only for structured data, but also for semi-structured and unstructured data. And again, HBase is for petabyte level data storage, but now the data accessing is in real time. This is a lot faster than many other databases in industry. And above it, we can find many names. These are nothing but just computing engines as well as for data statistics, analysis, and mining. Although MapReduce is good at dealing with large amount of data, it has its own several drawbacks. For example, it requires some Java programming skills, and it is not fast enough. So we need more tools in different cases. Like Hive, it is just an interactive data warehouse, and you can use SQL statements to do big data analysis, which is a lot easier to use than that of MapReduce. And for Pig, it also offers simplicity compared with MapReduce, but people prefer Hive, so we are not going to introduce it in our course. And for Spark, it is a memory-based computing framework, which is about 100 times faster than MapReduce. And besides, it provides distributed machine learning libraries, which is also very powerful. Flink is a pure stream processing engine, which is event-driven, so it is even faster than Spark in many cases. So they are what we can use to do data analysis. And on the left, you can find 3 tools for data collection. After all, we need some tools to help us collect the data into the system, right? So Scoop here helps to import data from databases like MySQL into Hadoop or export results back to databases. And Flume helps to monitor some data sources and help to automatically collect new data in real time. Kafka helps to deliver messages to different consumers, just like an newspaper boy. So again, we can rely on these tools for data collection. And finally, on the right-hand side, you can find Zookeeper, which is a distributed collaboration service. Because we have many servers in the same cluster, and different servers may have different roles and different responsibilities. So how to manage the roles and the responsibilities and how to monitor the working status for different servers, we can use Zookeeper to do that. And here you can find how a typical Hadoop big data processing process looks like. And this is actually an offline processing process because we are using MapReduce and Hive instead of Spark or Flink. So if we need to analyze some logs from a web server, firstly, we can use Flume to collect data automatically and store data into HDFS. Then With MapReduce, we can do some data cleansing, and then Hive can be used to do some basic data statistics or even data mining. After that, the result can be exported by Scoop, and hot data can be stored to HBase for efficient data query. And finally, we can do some data visualization by reading data from HBase. So perhaps we have talked too much and you may find it difficult to remember. Don't worry, here we have given you a basic summary of all the components we mentioned before, as well as their major responsibilities. Since we have already introduced them before, I will not repeat it right now. If you find any interest, please have a recall based on this page together with all the introductions before. And finally, we can conclude this chapter by taking a look at the characteristics of Hadoop. Firstly, it has a very high reliability and fault tolerance. This is because Hadoop can do data replication automatically, and the default replication factor is 3. So we say it is 3 replicas. This means that if there is 1 copy lost, we still have 2 more copies. And different copies are also distributed to different servers to improve its fault tolerance. Secondly, high availability. In a Hadoop cluster, if any one node fails, it does not disable the entire cluster. Instead, another node takes the place of the failed node. The Hadoop cluster will continue to run because nothing happens, which improves the reliability. Thirdly, high scalability. As we mentioned before, Hadoop shares nothing and it uses distributed architecture. So Hadoop is inherently highly scalable. If you need to scale up or down a cluster, simply change the number of servers and do some configuration modification. That's enough. Firstly, cost-effective. Because Hadoop shares nothing, so there is not a very strong requirement on the performance of each server. So Hadoop can be deployed on commodity hardware in cheap machines. This makes Hadoop very cost-effective. In addition, because Hadoop is open system software, there are no licensing costs. And as for the last 2 features, in fact, all tasks, no matter storage or processing, are distributed into many servers in Hadoop. We call this idea as divide and conquer. For processing, any job submitted by the client is divided into subtasks. These subtasks are independent of each other. They are therefore executed in parallel to provide high throughput. And for storage, Hadoop splits each file into multiple data blocks. These blocks are distributed on a cluster of machines. So that's all for this chapter, and here is a very short summary. In this chapter, we introduced some problems with traditional data processing and show you the data processing technology evolution trend. Then we talked about the overview of Hadoop ecosystem architecture, and finally, we introduced some characteristics of Hadoop. Hope you enjoy all the contents in this chapter, and see you in the next chapter.